So, hello, fellow Earthlings. This is Earthling 64554637728. And this is my attempt at explaining the channel Veritasium's quantum entanglement and spooky action at a distance video. I love science. I love science. I love science. Love science. And I don't often do anything like this. But anyway, I'll go into it in a second. So I am Earthling, yada, yada, yada. I have an MBA, I have a computer science degree. I got a scholarship a long time ago. I had a newspaper that I ran for a short while. It came out every 6 months. It wasn't every day, but I did everything. I traveled a lot. Venezuela, Grand Canyon, Czech Republic, and that's it for me. So anyway, while I am trying to study special relativity, and I realized that you need to know a good bit of math to really grasp it. So I started doing that. A friend of mine decided he would join me, and he sent me a video about pilot wave theory and the fact that there might be hidden variables. So I recalled that Veritasium had done a video on hidden variables and determinism. So I sent it to my friend, and it was basically a video on quantum entanglement and spooky action at a distance. Now, it was a long time since I actually had seen the video. I just sent it to my friend because I knew there was stuff in it that was slightly relevant. But my friend asked me a question about what was in the video, so I had to go looking at it again. And I realized, whoa, this is kind of so hard to understand. And I looked in the comments, and that's what everybody was essentially saying. This thing is so hard to understand. I don't really grasp it. I understand everything before the first second. So I thought, okay, I'm going to have to watch this video a number of times in order to be able to explain anything to my friend. And the whole idea with this video is, well, not the whole idea. I think the main theme is that there was faster than light transmission of information involved. And the whole idea is that if you have two particles that are entangled, they have a specific kind of relationship. You can have one particle that you detect one of its properties called spin at one end of the universe, and you can have the other particle that is entangled being detected at the opposite end of the universe. And whatever the spin is for the particle at one side of the universe, the other particle is going to have the opposite spin. So the idea is that how can you're going to know something about something that's happening on the opposite side of the universe instantaneously. So it seems as if information is traveling faster than the speed of light. So I think one of the ideas is that Einstein proposed that perhaps there were some hidden variables, meaning that there was a decision made when the particles were created, when they first left each other, that, hey, I'm going to have spin up, you're going to have spin down under these circumstances. Anyway, what Derek from Veritasium was expanding on was that a scientist came up with an experiment to determine if that was true. And you have two detectors that are going to measure the spins of these two different particles, let's say at opposite ends of the universe. And each of the detectors has like three, let's call them sub-detectors, sort of, that are each at an angle of 120 degrees to each other. I had to stop for a minute there to figure out, it's three sub-detectors and they all, yeah. So the idea is, if you measure the two particles at with a sub-detector, let's say, that is aligned in the same direction, then they have to have opposite spins when you measure. So there's one that's pointing straight up, and there are two that are pointing I guess you could say it's not exactly diagonally, but they're both pointing down to the left and right, right? And the idea is if both of the particles go to the detector that's pointing straight up, one of them has to have a spin of up, and the other one has to have a spin of down. Now, if you are suggesting that the particles have to have opposite spins based on hidden variables, meaning that they each have information that they carry with them that we don't know anything about, that determines what spin they're going to have before they leave each other. So you create the two particles, they're entangled, they go to opposite ends of the universe, and they already know, they've already had a plan to say, hey, if both of us go through the detector that's pointing up, you're going to be up, I'm going to be down. If we go to the one that's pointed, let's say downwards to the east, you're going to be up, I'm going to be down. And the whole idea is, since you're talking about a plan, that they have a plan as to what they're going to do, you can write down that plan. You can show that before they leave, they've all decided that, okay, particle A, you are always going to be up. No matter what detector you go through, you're always going to be up. Particle B, no matter what detector you go through, you're always going to have a spin of down. And since it's a plan, that's one arrangement that you can look at. And if you take a hard look at that first arrangement, what you realize is that since this particle A is always going to be up, it means that it doesn't matter what, and the other particle is always going to be down, it doesn't matter what detector the second particle is going through. No matter what detector that the first particle goes through and its spin is measured to be up, the other particle spin is always going to be measured to be down. So you can map out all those arrangements and you can see that 100% of the time they're going to have opposite spins, because they've already decided that first particle, he always has a spin of up, second particle always has a spin of down. They're always going to have opposite spins. The second arrangement that you can see when you brute force this whole thing and you plan it all out is that you're going to see that two of the first particle's measurements can be up and a third can be down. And the other one has to have the opposite arrangement to that. So wherever the first particle is decided that it's going to have two up, the other particle has to have two down. And wherever the first particle, one of three, is down, the other particle has to be up. And you can see that that pattern where you differ by one covers any other arrangement that you can come up with. And I realize now that I'm catering to people who have seen this video maybe at least once or twice, but yeah. But the whole point of it is, it's that if you believe in hidden variables, you can see exactly what the likelihood is that when you measure one particle, it's going to have a particular spin compared to another particle. You can see exactly what the percentages are going to be because you can map everything out. And when you map everything out and you compare it to reality, in reality, it doesn't map up. What you get, assuming that there was a plan beforehand, is not the values that you get when you actually test these particles, these entangled particles. And so, for example, as I was saying, there are two arrangements that you can decide on where the first particle says, I'm always going to be up. The other one says, I'm always going to be down. And then the second arrangement that can happen in a number of different ways, but they're all the same, is that the first particle decides, I'm going to be in 2 times out of 3, I'm going to be this way. And the second particle says, okay, well, 2 times out of 3, I'm going to be the opposite way. And the percentages, Derek didn't go into the average percentage, but the the arrangement ends up being that you expect the particles to be different between 100% and 5/9 of the time. When you actually observe it, they're only different. And this is the thing, they don't have to be different if the sub-detectors that they go through are not aligned in the same direction. They don't have to be different. They can be, depending on kind of whatever you want. And the idea simply is that when you ask quantum mechanics, hey, can you figure this out? Because when we tried to use hidden variables and we mapped everything out beforehand, it didn't work. So, hey, quantum mechanics, based on your ideas of the probabilities of detecting the spins under different conditions, do you come up with the right number? And quantum mechanics does. It comes up with the measurement that you actually see in reality. So it just becomes an idea of, hey, do you believe that this idea of hidden variables, which is not mapping up with reality, how can that be right if quantum mechanics is mapping up with reality? Even if it does seem as if information can, be transmitted across the universe instantaneously. Now, I don't know if I have actually managed to, break this information down in a way that's actually useful to anybody else, but I know that when I first looked at this video and I was like, oh my God, I don't understand this at all. And now that I think I understand it, it kind of all seems like a little bit mundane. So I don't know if I'm just being thinking that I understand it and I grasp what's going on and I have no idea. I don't think so. But when I compare it to, it's a brute force attack. Basically, it's like, hey, so you believe in hidden variables? Okay, great. They're hidden, and let's see what could be in them. And you just calculate all the different arrangements based on how the experiment is set up. And you realize that the deductions that you make and the information probabilities that you come up with based on your assumptions that it can't be true, that they've decided beforehand. Because if they had, they would have to follow what you've laid out. And if they have to follow what you laid out, they'd come up with the probabilities that you come up with, and they don't. So that's it. So hopefully this helps some other people. Hopefully they see it. I don't know. I hope so. So that's it for me. Feel free to like, subscribe, comment, unlike, all the things that people can do on YouTube, with the idea that, hey, do unto others as you'd like done unto yourself. Have a good one. Peace.